Welcome to Client-Side JavaScript with DOM.
After watching this video, you will be able to describe the document object model, or DOM, hierarchy, describe the window and document objects, identify the DOM objects that are commonly used in JavaScript applications for working with HTML documents. The document object model is the programming interface between HTML or XHTML and JavaScript. The Document Object Model, or DOM, is a browser-based interface for applications and scripts to dynamically access and update the content, structure, and style of documents. JavaScript uses the DOM to access and modify web page elements in the web browser. The World Wide Web Consortium released 4 levels of the Document Object Model specifications. Each successive level provides a more detailed set of features for describing structured documents. The different browsers have various levels of compatibility with the DOM standard. The discussion of the DOM in this unit focuses on the DOM Level 1 core and DOM Level 1 HTML APIs to access HTML elements with the DOM. The JavaScript engine in most web browsers fully supports DOM Level 1. Here is a representation of the basic DOM model for browsers. The window object is at the top of the DOM hierarchy and controls the environment that contains the document. The history object keeps internal details about the recent history of pages in the browser. The history object has methods for letting you simulate clicking the back or forward buttons in a browser. The location object contains information about the URL of a page. The navigator is an object representation of the client internet browser or user agent. There is no standard that applies to the navigator object, so the property values returned when running queries on the navigator object are not consistent across browsers. The screen object is used to derive information about a user's screen, such as the dimensions of the display screen. The screen object is useful for determining the screen size of browser windows that run on mobile devices. The document object provides access to all HTML elements within a page. Each HTML document that gets loaded into a window becomes a document object. The window object is the outermost global container of all the objects in the DOM hierarchy. When the browser loads a page, a window object is automatically created for you. You can then access the window object properties and functions from your JavaScript code. In client-side JavaScript, the window object serves as the global object, and everything in the DOM takes place in a window. A number of predefined methods exist for the window object. The window.alert, window.confirm, and window.prompt dialogues that are used in web pages come from the global window object. You can leave out the window prefix for methods in the DOM API, so the window.alert method can be coded more simply as alert with a message argument. This figure shows the object model for a simple HTML document. Notice how the object hierarchy matches the HTML containment hierarchy on the left. The object diagram can also be represented as a tree structure that corresponds to the structure of the HTML document. The branches of the tree structure are termed nodes. There are 2 types of nodes in the W3C DOM: element nodes and text nodes. All HTML tags, HTML, head, meta, title, and body, are element nodes. The nodes that contain actual text that go between an element's start tag and end tag are text nodes. The figure shows the DOM Level 2 tree for the form portion of the document. The line feeds between elements are text nodes and are part of the DOM Level 2 tree. The DOM Level 2 tree includes a line feed text node before the paragraph and input elements. The input element includes a text node that contains all the text that follows the input tag. An additional line feed text node follows the input element. The DOM Level 0 for the form portion of the document would have only the form, P, and input boxes. The DOM Level 2 adds the carriage returns, tabs, and spaces, sometimes referred to as white space. In this video, you learned the Document Object Model, or DOM, is the programming interface between HTML or XHTML and JavaScript. Each successive level of the DOM provides a more detailed set of features for describing structured documents. Different browsers have different levels of compatibility with the DOM standard. The basic DOM for browsers is a hierarchy that includes objects that perform different functions. For example, the window object controls the environment of the document. The location object contains information about the URL of the page. Screen object derives information about the user's screen. And the document object provides access to all HTML elements within a page. DOM levels define object types, with which developers can build a variety of documents, from plain HTML documents for web pages to more complex forms.
Hello, welcome to Overview of Web and Cloud Development.
When you're starting out as a web developer, it can be difficult to determine what you need to learn and what order you should learn it in. Understanding how familiar websites are constructed and delivered to you is a good starting point. Let's review the basics of how you interact with a website. You launch an internet browser. There are lots available. Google Chrome, Microsoft Edge, Mozilla Firefox, and Apple Safari are some of the most popular. The browser has an address bar into which you enter a URL, like www.ibm.com. The browser then contacts the server with the name and requests the information that makes up the website. The server then sends a response, which contains the data that the client requires to display the website. For most websites, the server will return HTML, which defines the structure of the page but doesn't look very attractive, CSS, which adds style and flair to the page, and JavaScript, which adds interactivity and dynamic content. Content displayed by websites can contain elements that are either previously stored on the server, called static, or generated each time they are requested by the client, called dynamic. Dynamic elements can involve information coming from other systems and applications, such as databases. Most websites contain static and dynamic elements to provide the best user experience. Cloud applications are similar to websites in that they request content that a server returns. Cloud apps are built to work seamlessly with a cloud-based back-end infrastructure, cloud-based data storage and data processing, and other cloud services, making them very scalable and very resilient. The environment for building websites and cloud applications is divided into two primary areas, front-end and back-end. The front end deals with everything that happens at the client side, everything the user can see and interact with. You can choose to specialize in front-end coding using HTML, CSS, JavaScript, and related frameworks, libraries, and tools. The back end deals with everything that happens on the server before the code and data are sent to the client. The back-end coding usually handles the logic and functionality that make the website or app work, and the authentication processes that keep data secure. Back-end developers may also work with relational or no SQL databases, even collaborating with database administrators in bigger projects. Full-stack developers have skills, knowledge, and experience in both front-end and back-end environments. Whichever way you choose to specialize, you will need the appropriate tools to help you work. The first tool most developers add to their resources is a code editor. Developers also need tools to integrate, build, compile, and debug code. Integrated development environments, or IDEs, incorporate some of these additional capabilities beyond just code editing and make it easier to build and manage your code. Good IDEs support multiple languages and integrate with management and storage tools like Git and GitHub. Other useful features are custom extensions and themes for supporting your working style and environment. Examples for code editors and IDEs include Sublime Text, Atom, Vim, VS Code, Visual Studio, Eclipse, and NetBeans. In this brief overview, you learned about the basic communication between client and servers, how websites are built and displayed. Front-end development is about what happens on the client side. Back-end development is about what happens on the server. Full-stack development includes both front-end and back-end development. IDEs will help you create and manage your code.
Hello, welcome to Overview of Web and Cloud Development.
When you're starting out as a web developer, it can be difficult to determine what you need to learn and what order you should learn it in. Understanding how familiar websites are constructed and delivered to you is a good starting point. Let's review the basics of how you interact with a website. You launch an internet browser. There are lots available. Google Chrome, Microsoft Edge, Mozilla Firefox, and Apple Safari are some of the most popular. The browser has an address bar into which you enter a URL, like www.ibm.com. The browser then contacts the server with the name and requests the information that makes up the website. The server then sends a response, which contains the data that the client requires to display the website. For most websites, the server will return HTML, which defines the structure of the page but doesn't look very attractive, CSS, which adds style and flair to the page, and JavaScript, which adds interactivity and dynamic content. Content displayed by websites can contain elements that are either previously stored on the server, called static, or generated each time they are requested by the client, called dynamic. Dynamic elements can involve information coming from other systems and applications, such as databases. Most websites contain static and dynamic elements to provide the best user experience. Cloud applications are similar to websites in that they request content that a server returns. Cloud apps are built to work seamlessly with a cloud-based back-end infrastructure, cloud-based data storage and data processing, and other cloud services, making them very scalable and very resilient. The environment for building websites and cloud applications is divided into two primary areas, front-end and back-end. The front end deals with everything that happens at the client side, everything the user can see and interact with. You can choose to specialize in front-end coding using HTML, CSS, JavaScript, and related frameworks, libraries, and tools. The back end deals with everything that happens on the server before the code and data are sent to the client. The back-end coding usually handles the logic and functionality that make the website or app work, and the authentication processes that keep data secure. Back-end developers may also work with relational or no SQL databases, even collaborating with database administrators in bigger projects. Full-stack developers have skills, knowledge, and experience in both front-end and back-end environments. Whichever way you choose to specialize, you will need the appropriate tools to help you work. The first tool most developers add to their resources is a code editor. Developers also need tools to integrate, build, compile, and debug code. Integrated development environments, or IDEs, incorporate some of these additional capabilities beyond just code editing and make it easier to build and manage your code. Good IDEs support multiple languages and integrate with management and storage tools like Git and GitHub. Other useful features are custom extensions and themes for supporting your working style and environment. Examples for code editors and IDEs include Sublime Text, Atom, Vim, VS Code, Visual Studio, Eclipse, and NetBeans. In this brief overview, you learned about the basic communication between client and servers, how websites are built and displayed. Front-end development is about what happens on the client side. Back-end development is about what happens on the server. Full stack development includes both front-end and back-end development. IDEs will help you create and manage your code. Internet websites offer lots of different services, one of the most popular being online shopping. When you explore an online shopping website, navigating through pages, choosing different product categories, or comparing products, you are interacting with the front end of a website. Let us see how the front end of a website is developed by front-end developers. For this, we need to understand how a website is made. To create a website, web developers usually use hypertext markup language, HTML, cascading style sheets, CSS, and JavaScript. These languages are designed to work in conjunction with each other. HTML is used to create the physical structure of a website. The physical structure contains elements such as text, links, images and videos, page dividers, and buttons. The HTML code ensures a proper formatting of all text and image elements so that browsers display the page consistently. The backend developer codes the structure of the website. A website is like a house which has only been constructed. Just like we need interior designers to add style to a space, we need front-end developers to add the necessary glamour and appeal to a website. When you order products from any website, you realize that the pages have a pleasing font, attractive colors, and are easy to navigate. Developers use CSS to create stylish websites. CSS provides front-end developers with a standard method to define, apply, and manage different sets of style characteristics for a website and each of its components. CSS ensures uniformity in look and feel, style, colors, fonts, designs, and layouts. So, HTML is used to create the structure, and CSS is used to design it and make it appealing. CSS is also used to create websites that have cross-browser compatibility, which means that they are compatible with multiple browsers and multiple devices, such as PC, mobile devices, iPads, etc. Online shopping websites are intuitive, interactive, and quick to load. This is where JavaScript comes into the picture. JavaScript is an object-oriented programming language that is used in conjunction with HTML and CSS to add interactivity to a website. For example, you use HTML to add a login button to a page and CSS to style that button. Then you use JavaScript to add login functionality to that button. A new front-end development language is Syntactically Awesome Style Sheets, SASS, called Sass. It is an extension of CSS that is compatible with all versions of CSS. Sass enables you to use things like variables, nested rules, and inline imports to keep things organized. Sass allows you to create style sheets faster and more easily. Another language that is being used now is Learner Style Sheets, LESS, or LESS. LESS enhances CSS, adding more styles and functions. It is backwards compatible with CSS. Less.js is a JavaScript tool that converts the LESS styles to CSS styles. Using all these languages, websites are designed as reactive and responsive. Reactive, or adaptive websites, display the version of the website designed for a specific screen size. For example, a website can provide more information if opened on a PC than when opened on a mobile device. Responsive design of a website means that it will automatically resize to the device it is being accessed from. For example, if you open up a product's website on your mobile device, it will adapt itself to the small size of the screen and still show you all the features. A JavaScript framework is an application framework that is written in JavaScript. Programmers can manipulate the different functions, use them wherever required, and can create device-responsive applications. A few examples of several frameworks being used are Angular framework, an open source framework being maintained by Google. Angular frameworks allow websites to render the HTML pages quickly and efficiently. It has built-in tools for routing and form validation. React.js has been developed and maintained by Facebook. It is a JavaScript library that builds and renders components for a web page. It is not a complete suite of tools. For example, routing is not a part of this framework and will need to be added using a third-party tool. React.js only helps build and drop components into a page. Vue.js is maintained by the community, and its main focus is the view layer, which includes user interface, buttons, and visual components. It is flexible, scalable, and integrates well with other frameworks. It is very adaptable. It can be a library or it can be the framework. The task of a front-end developer evolves continuously. The technologies are upgraded constantly, and so front-end developers need to keep upgrading the websites that they create. The websites that they create should work in multiple browsers, multiple operating systems, and multiple devices.
Welcome to Insider's Viewpoints, front-end and back-end web development. In this video, we will listen to several web development professionals discuss front-end and back-end web development. So, can you talk about front-end and back-end development and describe some of the languages, IDEs, tools, and frameworks you commonly use for each?
Front-end development or client-side programming is what happens in the browser. It is everything that the user sees and interacts with. Some of the languages we use for front-end development are HTML, CSS, JavaScript. We use framework and libraries like AngularJS, React, and jQuery, Backbone.js, etc. Back-end development or server-side programming happens on server and database. It enables the front-end user experience. We use back-end languages like Python, Java, Node.js, JavaScript. Some of the backend framework used are Django, Rails, Spring, etc.
Front-end traditionally means working on things that the user can see, the user can touch, and have a direct interaction with. All right, so this could be the design of your application or your website, the way the different buttons are placed. It could also be how the user interacts. So clicking, for example, could be one use case of a front-end development and design. Back-end, on the other hand, supports your front-end, right? So back-end is developing services that enable user to perform a function, but the user does not directly interact with. So thinking of for example, if you're building a retail application, the front-end could be the shopping cart and clicking on the little button to add something into your shopping cart. And then the back end would be processing that. It could be processing your credit card, it could be invoicing, it could be shipment, or actually shipping the product to the end user. All of that, all of the services that enable that goes into the back end.
Our team uses a lot of Ruby on Rails, mixed with some Vue.js. Some of our newer projects we're moving to Elixir and Phoenix. We also have a lot of services written in Node.js, and some of them use TypeScript as well. We also have a lot of Python code written with Django and Flask.
I started off with front-end development and quickly got into back-end so that I could write the full stack, and quickly also became interested in the infrastructure underlying it. I started off using Atom, and then I quickly, after getting more into the cloud, wanted to have more integrations like AWS Toolkit and Terraform plugins and CloudFormation linters. Tools that helped me format my code in an intelligent way. So VS Code is the tool I've been using to write my CloudFormation templates, and Terraform templates and Python scripts in the past. And now.
In terms of different frameworks for the front end, I traditionally rely on HTML, CSS, obviously, to create and style the front end application. I also use frameworks like Bootstrap that make it a little bit easier to create some of the more complicated design structures. For the backend, I for most part focus on JavaScript or Python. I use Node.js and Express.js extensively. I also use Python frameworks like Flask and Django when working with when creating services on the backend. Since I'm a cloud native developer, I also use Cloud Functions, which is the serverless platform on the IBM Cloud, quite a bit.
I'm generally doing back-end development, but I do dabble in front-end and touch some front-end code from time to time. For both, I use VS Code to pretty much do all of my development, although if I'm logged into a server, I can use VI or Nano for a terminal experience. For my front-end development, I'll use often the same languages like Ruby or JavaScript, but sometimes there's a little bit of derivation or I have to learn a specific templating language. And there are a number, Handlebars, Jinja, so on and so forth. And honestly, I Google it every single time. And that goes the same with front-end frameworks. There's a number of them. There's a lot to them. So generally, learn the basics and dig when you need to dig.
Welcome to Introducing Application Development Tools. Getting your cloud app from the idea stage to fully formed, written, and deployed is a long process, but there are many tools which will help you along the way. A cloud application developer's workbench includes version control, libraries, and frameworks. When many developers are working on the same project, knowing what order changes were made, thereby creating a new version of the source code, becomes overridingly important. Version control systems keep track of what changes were made when and by whom, and resolve any conflicts between changes. For developing your code, version control can be useful even when you are the sole contributor on a project. Properly used, it can give you a way to revert to an older version of your code if something goes wrong, and gives you some basic information about how the code developed over time. Version control functionality is generally tied to the storage system you are using, which is why a code repository is recommended, even for beginners. Git and GitHub are extremely popular for source code storage and management. Git stores files in repositories where you can track changes, split code into different branches for more focused development, and then merge them back into the main body of code. Libraries are collections of code, like standard programs and subroutines that you can use within your code. For example, you might want to include a navigational feature, like a carousel. A code library can supply you with the code for that so that you don't have to spend the time and energy creating one from scratch. Being able to reuse code in this way makes developing your app much quicker and easier. Multiple code libraries can be integrated into your existing project. As you discover a need for a specific function or feature, you can research an appropriate library. You determine when to call the required method as needed. The control returns to the program flow once the subroutine is finished. When you use a code library, you are in control. Code libraries are generally used to solve a specific problem or add a specific feature set. Either way, there are lots for you to choose from, so do your research. Here are some examples of code libraries. jQuery is a JavaScript library that simplifies DOM manipulation. Email Validator is a small library that checks an email address is correctly constructed and valid. Apache Commons Proper is a repository of reusable Java components. Frameworks provide a standard way to build and deploy applications. You can think of a framework as being a skeleton that you can extend by adding your own code, providing a scaffold on which to build your apps. The framework you intend to use must be determined early in your development planning and used right from the beginning. New frameworks can't be incorporated into an existing project. Your chosen framework dictates the architecture of your program and controls the program flow. The framework determines which subroutines and methods will be called when. When working with a framework, there is a specific structure that you must follow. The framework calls on your code rather than you calling on the framework. Frameworks are less flexible than libraries, allowing you less control, but they do provide good standardization and can help you create efficient code. To use an analogy, if you are a carpenter building a house, the framework is the frame that you add to, bricks on the outside, plasterboard on the inside, and so on. The frame acts as a guide for how the house is constructed. Here are some examples of frameworks. AngularJS is a JavaScript-based framework for dynamic web applications. Vue.js is a JavaScript framework focused on the user interface. Django is a framework that uses Python for web development. Frameworks define the workflow that you must follow, unlike libraries, which allow you to call functions as and when required. When using a framework, it can sometimes feel like you, as a developer, are not in full control of the development process. This sense of the framework and its predefined workflow controlling the development process is referred to as inversion of control. Frameworks that have a lot of control are known as opinionated. They have opinions on how their workflow should be used and remove a lot of the decisions you would otherwise have to make about how code is written, the location of files, and even file names. Frameworks often include their own libraries, which they can call when needed. Inversion of control allows you to create standardized apps and takes away a lot of the tedious configuration work, so you can focus on the code for your app. In this video, you've learned about some of the tools that you will utilize in your career as a developer, including version control, libraries, and frameworks. Welcome to Introducing Application Development Tools. Getting your cloud app from the ideas stage to fully formed, written, and deployed is a long process, but there are many tools which will help you along the way. A cloud application developer's workbench includes version control, libraries, and frameworks. When many developers are working on the same project, knowing what order changes were made, thereby creating a new version of the source code, becomes overridingly important. Version control systems keep track of what changes were made when and by whom, and resolve any conflicts between changes. For developing your code, version control can be useful even when you are the sole contributor on a project. Properly used, it can give you a way to revert to an older version of your code if something goes wrong, and gives you some basic information about how the code developed over time. Version control functionality is generally tied to the storage system you are using, which is why a code repository is recommended, even for beginners. Git and GitHub are extremely popular for source code storage and management. Git stores files in repositories where you can track changes, split code into different branches for more focused development, and then merge them back into the main body of code. Libraries are collections of code, like standard programs and subroutines that you can use within your code. For example, you might want to include a navigational feature, like a carousel. A code library can supply you with the code for that so that you don't have to spend the time and energy creating one from scratch. Being able to reuse code in this way makes developing your app much quicker and easier. Multiple code libraries can be integrated into your existing project. As you discover a need for a specific function or feature, you can research an appropriate library. You determine when to call the required method as needed. The control returns to the program flow once the subroutine is finished. When you use a code library, you are in control. Code libraries are generally used to solve a specific problem or add a specific feature set. Either way, there are lots for you to choose from, so do your research. Here are some examples of code libraries. jQuery is a JavaScript library that simplifies DOM manipulation. Email Validator is a small library that checks an email address is correctly constructed and valid. Apache Commons Proper is a repository of reusable Java components. Frameworks provide a standard way to build and deploy applications. You can think of a framework as being a skeleton that you can extend by adding your own code, providing a scaffold on which to build your apps. The framework you intend to use must be determined early in your development planning and used right from the beginning. New frameworks can't be incorporated into an existing project. Your chosen framework dictates the architecture of your program and controls the program flow. The framework determines which subroutines and methods will be called when. When working with a framework, there is a specific structure that you must follow. The framework calls on your code rather than you calling on the framework. Frameworks are less flexible than libraries, allowing you less control, but they do provide good standardization and can help you create efficient code. To use an analogy, if you are a carpenter building a house, the framework is the frame that you add to, bricks on the outside, plasterboard on the inside, and so on. The frame acts as a guide for how the house is constructed. Here are some examples of frameworks. AngularJS is a JavaScript-based framework for dynamic web applications. Vue.js is a JavaScript framework focused on the user interface. Django is a framework that uses Python for web development. Frameworks define the workflow that you must follow, unlike libraries, which allow you to call functions as and when required. When using a framework, it can sometimes feel like you, as a developer, are not in full control of the development process. This sense of the framework and its predefined workflow controlling the development process is referred to as inversion of control. Frameworks that have a lot of control are known as opinionated. They have opinions on how their workflow should be used and remove a lot of the decisions you would otherwise have to make about how code is written, the location of files, and even file names. Frameworks often include their own libraries, which they can call when needed. Inversion of control allows you to create standardized apps and takes away a lot of the tedious configuration work, so you can focus on the code for your app. In this video, you've learned about some of the tools that you will utilize in your career as a developer, including version control, libraries, and frameworks.
Welcome to Insider's Viewpoints, Tools and Technologies. In this video, we will hear from experts discussing their favorite tools and technologies for web development projects.
So if you are a front-end developer, if you understand JavaScript, then picking up backend using a framework like Node.js is not that much of a stretch. I actually started building static websites and then slowly learned how to put in dynamic content using JavaScript. And then I had to use Java or PHP to build my backend systems on the server.
For front-end development, you're primarily using HTML, CSS, and JavaScript. If you're very front-end focused, you might want to try out an IDE built for that specific purpose, such as brackets. If you want to keep things more general, I recommend VS Code. In either case, I recommend installing IDE extensions for automatic formatting and linting of your code using Prettier and ESLint. These will help you catch issues as early as possible. For backend development, the tools are quite a bit more varied, so it's hard to give specific recommendations, but if you choose Node.js, you'll be able to use some of the same tools that I mentioned for front-end development. Otherwise, I recommend just looking into what IDE extensions are available and what linters and auto formatters are available.
JavaScript is a very powerful language. It lets you do pretty much anything you can imagine, including shooting yourself in the foot if you're not careful. The practices I typically follow with JavaScript include proper scoping of variables and functions, and writing unit and integration tests for my features.
React.js was developed at Facebook, very popular. Angular is a framework operated by Google that allows for development of single-page applications, SPAs. jQuery is possibly the most popular and oldest library out there, created by John Resig in 2006. And jQuery is frequently used with both Angular and React. Backbone is a lightweight JavaScript library that is very popular. In terms of backend languages and frameworks, Node.js is an open source server-side platform built on the Google Chrome JavaScript engine. It uses an asynchronous single-threaded architecture that allows it to serve a very large number of concurrent connections. Flask is a framework used on Python that is popular with Pythonistas. And the Spring framework based on Java has been around for years and remains popular.
We use React JavaScript framework. It is better than Angular in terms of speed and efficiency. React is easier to learn than other JavaScript frameworks, which makes its adoption in the team easy. It also resolves the problems related to cross-browser issues. Another great feature of React is the use of JSX. JSX is helpful when working with UI inside the JavaScript code. It helps React to show more useful error and warning messages.
My favorite front-end JavaScript framework would be React.js. I love the whole component-driven design and architecture that you have to follow when you create a React.js based application. I also like the idea of props and states to hold the state of your application.
By using Express.js for backend development, we are able to scale applications quickly. We can code both frontend and backend with the help of JavaScript easily by using Express.js. Express.js is supported with the Google V8 engine, with the help of which you would be able to get higher performance without any lag or error in processing. It also supports the caching features, so you would not have to re-execute the codes again and again. Moreover, it will help web pages to load faster than ever.
When working with Node.js, I'll give you two of my favorite packages that I use on a daily basis. So first is making requests to web services. I use a library like Axios that helps me create these requests with the right headers and also provide me with callback functions or promises to be able to handle the responses that come back. My second package would be when I'm working with databases. I'll use NPM packages more likely than not to talk to an external database, regardless of if it's a relational database or a NoSQL database.
So when writing JavaScript, I really like to take advantage of the features in ES6 because it can make my code look cleaner, easier to read, and just more beautiful, such as the arrow functions or the ... operator. And so I encourage you to, after learning JavaScript, dive into ES6 a bit and have fun with it.
Welcome to the importance of back-end development. A front-end developer creates websites and cloud applications using HTML, CSS, and JavaScript to create what the user sees and interacts with in the client software. A back-end developer creates and manages all the resources that are needed to respond to the requests that the user makes through the client. The back-end developer's tasks focus on enabling the server infrastructure, or back-end, to process requests, supply data, and provide other services securely. Front-end and back-end developers must work together very closely. Each needs to understand the requirements of the solution and how their respective parts will interact before the development process can begin. Throughout the lifecycle of the website or cloud app, front-end and back-end developers collaborate to resolve issues and add functionality. How does the work of a back-end developer affect you as you are browsing the internet or using a cloud app? Think about it like this. When you're shopping online, what happens to the data you enter? Your login information, your product searches, your payment info. The back-end processes all of these things, and the back-end developers write and maintain the parts of the application that process the inputs. Let's think about your experience as you explore an online shopping site and make a purchase. As you search for products, your search request is submitted to a web application, which then retrieves the data from a separate database and serves it back to the client for display. To facilitate this, a back-end developer must understand the language that the web application uses, how to query the database for the correct data, and how to bring the two together. Even a simple task like navigating around the site can require the skills of a back-end developer. Many sites have restricted areas that are only available to users who have an account and have logged in. User account management, authentication, and authorization can be the responsibility of the back-end developer too. Once you've decided what you want to purchase, you must add it to your cart and make a payment. The purchase process requires you to submit sensitive information, such as your address and credit card number, and the back-end developer must ensure that this data is securely handled and stored. Front-end client interactions, whether a request for data like an image, accepting input from a user filling out a form, or securing sensitive information like a credit card number, all require different services from the back-end server. Each request needs to interact with the back-end in a different way. Back-end developers use APIs, routes, and endpoints to process incoming requests. An API is code that works with data, usually using JSON or XML. APIs have set rules and structure. A route is a path to a website or page that the user interacts with. Routes generally take user input and show results based on the input. An endpoint may be an API or may simply be a path. When a request from the front end arrives at the back end, it is routed to the correct service. If the back end has an endpoint defined for the request by using routing, the request will be addressed and replied to. If the endpoint is missing, the server returns a 404 error. Back-end developers must create and maintain this server-side routing. Along with back-end APIs, routes effectively allow the front-end client to plug into the correct socket at the back-end. APIs provide a mechanism for cloud apps, mobile apps, and other types of software to access resources from the back-end. To perform all this back-end development, you will need to be familiar with at least one back-end language and its associated frameworks. Among the most popular languages today is JavaScript, which was originally designed to run in web browsers, adding extra interactivity and dynamic content to web pages. JavaScript is also being used on the back end, with new releases adding server-side functionality. JavaScript has many frameworks, but two of the most well-known are Node.js and Express. Python is another popular language. It's very flexible and easy to learn. Python has wide functionality. It can be used for everything from creating web pages to connecting to a database to performing data analysis. Two well-known Python frameworks are Django and Flask. Back-end developers often work with data and databases, so you will also benefit from learning some SQL. To help handle requests from databases, back-end developers can use Object Relational Mapping Tools, or ORM, to connect to the databases and retrieve the correct data. Although an ORM can hide some of the complexity of querying databases, It's useful to understand the fundamentals of databases so that you can troubleshoot any issues that arise. The day-to-day tasks of a back-end developer focus on the behind-the-scenes functionality that keeps websites, cloud apps, and mobile apps up and running. Back-end development covers a wide range of technologies, from managing user accounts, authentication, and authorization, to ensuring that sensitive data is stored and transferred securely. Back-end developers also work with databases, retrieving, processing, and storing data as required. Life for a back-end developer is varied, challenging, and ever-changing. Hello, and welcome to Introduction to HTML. After watching this video, you will be able to explain what Hypertext Markup Language, or HTML, and HTML5 is, and list the objectives of HTML5. The core HTML specification includes this background information. HTML stands for Hypertext Markup Language, which can be thought of as the language of the Internet. It is a markup language that was originally designed for sharing scientific documents. Adaptations to HTML over the years have made it suitable to describe a number of other types of documents that can be displayed as web pages on the Internet. HTML elements are the building blocks of an HTML page. The pieces of content that form the page are assigned labels, such as paragraph, list, and table. They are represented by tags. Browsers do not display the tags, but use them to render the content. HTML has been in continuous evolution since it was introduced to the Internet in the early 1990s by CERN, the European Organization for Nuclear Research, and the IETF, Internet Engineering Task Force. The World Wide Web Consortium, or W3C, made a number of recommendations to the HTML standards over the years. New features were continually added, and specifications changed over time. Initially, the Web Hypertext Application Technology Working Group, or WHAT-WG, worked on recommendations independently. Then, in 2007, W3C formed a working group chartered to work with the WHAT-WG on the development of the HTML5 specification. The W3C published the specification under the W3C copyright, while a version with a less restrictive license was kept on the WHAT-WG site. Since 2007, both the W3C and the WHAT-WG groups work together on the development of the HTML5 standard. The HTML5 specification, as drafted by the W3C, includes the following objectives. The HTML5 specification defines a single language called HTML5 that can be written in HTML or XML syntax. The HTML5 specification defines a processing model that can interoperate with earlier HTML implementations. HTML5 improves the markup for documents. HTML5 includes markup and APIs for idioms such as web storage, video, and audio content. When speaking about creating web pages, developers may use the terms HTML and HTML5 interchangeably. In general, the term HTML implies HTML5. Use the full term HTML5 if you need to differentiate between versions, such as when discussing features new to HTML5. In this course, HTML refers to HTML5 unless specified otherwise. In this video, you learned HTML stands for Hypertext Markup Language, a markup language that enables documents to be displayed as web pages on the Internet. Tags represent the elements of an HTML page like paragraphs, lists, and tables. HTML5, the latest version, supports pages written in HTML or XML syntax, interoperation with earlier HTML versions, markup and APIs for web storage, video, and audio content. and welcome to HTML Features. After watching this video, you will be able to list some of the features of HTML5. Describe the document object model, or DOM tree. Explain when you would use XML and when you would use HTML. So, what are some HTML5 features? It provides the means to categorize web pages into different sections and includes tools for effective data management, drawing, video, and audio. Facilitates the development of cross-browser applications for the web and portable devices. Allows greater flexibility, permitting the development of exciting and interactive websites. Helps to create a more engaging user experience. Pages that are designed by using HTML5 can provide an experience similar to desktop applications. Allows for enhanced multiple platform development by combining the capability of an application programming interface, or API. By using HTML5, developers can create a modern application experience that is uniform across platforms and devices. Here is an example of a document that conforms to the syntax of HTML5. Documents that have the text or HTML media type are parsed using HTML rules. If a document is transmitted with an HTML content type, such as text or HTML, it is processed as an HTML document by web browsers. This example uses the following elements. The exclamation point doc type is a declaration tag that represents the document type. The exclamation point doc type declaration is not an HTML tag. It is an instructional to the web browser about what version of HTML the page is written in. Although this declaration is not required, it should be the first line of the HTML code if the developer decides to include it. The HTML tag is the root element of this tree. It contains all of the other HTML elements except the exclamation doc type tag. This example contains two elements, head and body. The head tag contains a title tag, which contains the text sample page in the example. The head element can contain the following tags: title, scripts, style, style sheet links, meta information, browser support information, and other initialization functions. Finally, the body tag contains all content that is displayed on the web page. HTML user agents, commonly known as browsers, parse the markup, turning it into a DOM, or document object model, tree. A DOM tree is an in-memory representation of a document. DOM trees contain several kinds of nodes, which include a doc-type node, elements such as headers and paragraphs, text nodes, and comment nodes. Here is an example of a document that conforms to the XML syntax of HTML5. Extensible Markup Language, or XML documents, look similar to HTML documents, except they have an XML tag on the first line. In addition, with XML documents, the content type must be specified as an XML media type, such as application or XML. When a document is transmitted with an XML content type, it is treated as an XML document by a web browser, and an XML processor parses the document. How do you decide whether to use HTML or XHTML for developing web pages? Which of the two options you choose is related to how you intend to use the application. For instance, are you using XSLT, or Extensible Style Sheet Language Transformations, to create other documents and resources from your web pages? People are equally divided about whether to use XHTML or HTML. Both HTML and XHTML use the same semantic, or tags. However, XHTML tags all need to be in lowercase, while the case used does not matter in HTML. In addition, XHTML must be well-formed. Every element must have an end tag. All attributes must have a value, and double or single quotation marks must surround all attribute values. If an XML parser encounters a situation where the syntax is not well formed, it stops processing. In HTML, different case, unmatched quotation marks, and non-terminated and uncontained elements are allowed and commonplace. In this regard, HTML syntax is less rigorous than XHTML syntax.
In this video, you learned that HTML5 includes features for categorizing sections of web pages and managing data, video, and audio tools. Enables you to develop a single cross-browser application for the web and portable devices, and helps you to create a more engaging user experience. The DOM tree is an in-memory representation of a document, and DOM trees contain nodes which define the type of document and its structure, such as headers and paragraphs, text nodes, and comment nodes.
Hello, and welcome to HTML Management and Support. After watching this video, you will be able to list some HTML document API properties and methods. Describe how scripting is enabled in browsers. Describe browser support for HTML5 features. So let's examine some of the key themes of the HTML5 specification. The syntax it defines is compatible with HTML4 and XHTML1 documents. HTML5 is defined in a way that is compatible with earlier versions in the way browsers handle deployed content. It separates conformance requirements for user agents and authors. In other words, how browsers treat HTML5 code and how page authors treat HTML5 code is different. For user agents, HTML5 is defined in a way that supports elements and attributes of the earlier specifications. For authors, several elements and attributes have been removed in order to simplify the language. HTML5 includes some elements and application programming interfaces that help in the creation of web applications. Examples include video and audio elements, and an API that supports the creation of offline applications. What do you think makes HTML suitable for creating web applications? There are a number of possible reasons. The range of devices that all have built-in browsers that support HTML5 features. The number of APIs that enhance the user experience, such as the advanced animation, drawings, audio, and video elements. The efficient use of HTML and CSS while reducing the number of images can lead to faster load times for rendering web pages. Search engine optimizations can use keywords that are taken from HTML attributes to improve the visibility of a website when search results are displayed. The meta tags shown are used to provide information to search engines. Here are some examples of elements in HTML5. New structural elements are part of the HTML5 specification. These markup elements help you to logically define the page structure. New APIs such as Canvas, audio, and video help with graphics and embedded content. New attributes were added to the input element attributes. Examples include the email, date time, and number types. The browser automatically validates the input field according to the input attribute, without the need for custom validation scripts. By using web storage APIs, you can store data in the browser. The Web Workers feature can be used for non-interactive processing. Web Workers provide a way to run processing-intensive tasks without blocking the user interactions to the current page. In this video, you learned about HTML5 themes, which provide syntax compatible with HTML4 and XHTML1, new and refined APIs for video and audio elements, offline web pages, and drag and drop. About HTML5 web applications, which have improved search indexing with meta tags, better page load times, enhanced user experience, and about HTML5 elements, which enable you to define and manage web page structure and content.
Welcome to HTML scripting. After watching this video, you will be able to define scripting, explain how browsers enable scripting, and identify DOM tree accessors. The use of scripting within a website, often through the use of JavaScript, can be done directly within your HTML code within the script tag or within a separate file which is called in your HTML code. Scripting provides a more interactive user experience when browsing websites. It can be used for various tasks such as form validation, dynamically changing the content of a website, and manipulating images. Since scripting can be turned off, the recommendation is to use scripting but not to rely on it. Scripting is enabled for a browser context when the conditions shown on the slide are true, the browser in use supports scripting, and the user has scripting enabled. HTML5 also defines a sandboxed media type which specifies an extra set of content restrictions and can be used when hosting untrusted content. This sandboxed browsing content can be set at the page level or specified as an attribute for embedded objects. Running a page that contains an embedded object without the sandbox attribute grants the embedded object the same permissions as the rest of your page. This implicity gives third-party vendors permission to run scripts with the same permissions that you have for that page, which is one way that you can inadvertently allow advertisements to occur in your application. So, to prevent granting implicit permissions to embedded objects, use the sandbox attribute on any tag that contains an embedded object.
Each HTML document that is loaded into a browser page becomes a document object. The document object provides access to all HTML elements in a page and can be accessed from within a script. The DOM tree accessors are HTML document APIs that provide access to all the HTML elements on a page. The property to access is prefixed by the word document. For example, document.head returns the first head element that is a child of the HTML element, if there is one, otherwise null. The function document.images returns an HTML collection of the image elements in the document. The function document.scripts returns an HTML collection of the script elements in the document. Here are some common HTML DOM tree methods. The document.getElementById ID function has one required parameter, which is the ID of the element you want to access. The ID is specified as an attribute on one of the elements that is coded elsewhere on the page. The document.getElementsByTagName tag function has one required parameter, which is the tag name of the element you want to access. This function returns a node list of all the elements with the tag that matches the required parameter. This is a fragment of HTML with JavaScript code that uses the document API. When Submit is clicked inside the page that is running in a web browser, the text checker function begins. The document.getElementById text field 1 retrieves the contents of what was typed into the input field that has the ID of text field 1 and places this content into a variable. The JavaScript logic then tests whether any data was typed into the field, and an alert dialog is displayed with the result. A similar function will be used later in exercise 1. Here is the output from running the code on the previous page that uses the document API. The user types test in the input field and clicks submit. The result is seen in an alert dialog box on the same page. In this video, you learned scripting is used to provide a more interactive user experience when browsing websites. Since scripting can be turned off, the recommendation is to use scripting but not to rely on it. Scripting is enabled when certain browser conditions are met. HTML5 sandboxes enable you to manage iframe mashups, web pages that pull content from more than one site. HTML documents loaded into a browser page become document objects, which you can access through scripts.
Welcome to HTML5 browser support. After watching this video, you will be able to explain how browsers support HTML5 features, list which browsers support which HTML5 features, and define browser support table.
Not all browsers fully support all the features that are described in the HTML5 and CSS3 specifications. For example, older versions of browsers do not support certain features. The developers of different browsers are continually adding support for HTML5 features to their new browser versions. For the most comprehensive support of HTML5 features, consider using Google Chrome. Support tables show which features are supported by which browsers and can be a useful tool when developing web pages. For example, caniuse.com has great support tables for HTML5, CSS3, and more. Here are the results of displaying the input type equals date element in different browsers. The Google Chrome browser displays a calendar to enter the data. The Microsoft Edge browser displays spinning boxes to enter the data. Notice the difference in date formats. year-year-month-month-day-day versus month-month/day-day/year-year-year. The Firefox browser displays the date field as a text field. This could raise several issues regarding input format and validation. This example shows a support table for the input type equals date element. The numbers represent the browser version. The color determines the level of support. Green, full support. Olive, partial support. Red, no support. Edge, Chrome, and Opera browsers are green, meaning they support the input type equals date element. Internet Explorer and Safari browsers are red, meaning they do not support the input type equals date element. Support levels change as developers of browsers add new features, so check back frequently to see if the features you require are supported. You can also use JavaScript to check whether a certain HTML5 element is supported by a browser. First, create a DOM element by typing document.createElement and include the element type as a parameter argument. As a result, the DOM object gets created. If the browser does not support that element, the DOM object that gets created has a set of common properties, but nothing specific for that element. You then test for a known property or method on the DOM object that you created. If that property or method does not exist, then the browser does not yet fully support the DOM element or the HTML5 tag that has been created. Browsers that do not support the element can revert to a fallback or default behavior, such as displaying the field as a regular text field. Here is an example of using JavaScript to check whether a certain HTML5 element is supported by a browser. This code is used to test whether the browser supports the element input type equals date/. In the example, you dynamically create the DOM object for the input element, and then you set the type attribute to the value of date. If the browser does not support the input type equals date, the field is displayed in the browser as a regular text field. In this video, you learned not all browsers fully support all the features that are described in the HTML5 and CSS3 specifications. caniuse.com has good support tables that show what features are supported by which browsers. You can use JavaScript to check whether a certain HTML5 element is supported by a browser.
Welcome to Insider's Viewpoints, working with HTML and CSS. In this video, we will listen to several professionals discuss their experience working with Hypertext Markup Language, or HTML, and Cascading Style Sheets, or CSS.
So a typical challenge when writing in CSS and you're kind of new at it is it can be hard to center an element perfectly in in a space, whether it be the whole page or within a box. It can be hard to center things really nicely. It might just be off a little bit. And for that, it was really helpful to learn Flexbox. So I encourage you to give that a shot and understand it and be comfortable with Flexbox.
While working with HTML and CSS, sometimes the main challenge is finding the errors or bugs in your code. It is important to validate your code frequently. You can use an online HTML and CSS validation service to make sure that the code is properly formatted and there is no missing parentheses, incorrect property names, etc. To find out any CSS errors, you can also use developer tools in browser. Another challenge is testing the code on different browsers. Some of the old browsers do not support modern HTML features. Once you have decided on the technologies you would be using, it is a good idea to research the browsers that would support these features. You should also add fallback mechanisms to your HTML code for browsers not supporting the new features. For example, if you're using HTML5 video, you can add a link to download video as a fallback option for browsers that don't support the HTML5 video player.
My answer is going to focus on CSS since it is far more complex than HTML. In my opinion, it's unthinkable to tackle cross-platform CSS without using a framework. So the challenge, becomes then, how do you pick your framework? And here's some ideas. Bootstrap is one of the most popular. It has powerful cross-browser capabilities. There's Foundation. It has a significant learning curve. There's the Materialize framework from Google, which has an optimized feature set that many developers value. There's also UIKit, which is most popular in iOS development.
Welcome to HTML5 Tags and Structural Elements. After watching this video, you will be able to list elements specific to HTML5, describe HTML5 structural elements, section, article, header, footer, figure, and fig caption, and explain the difference between navigation and grouping elements.
There are many HTML5 specific elements. The table shows some of them. Notice that the HTML5 element tags have intuitive names, such as audio, that is used to embed sound content, and canvas, that is used for graphical content. Not all of these element tags are covered in this video, so take a moment to read through the table. This table shows more HTML5 elements. The last tag in the table is the comments tag. Comments in HTML can assist the developer to explain what the code does. The browsers do not display these comments unless the viewer views the source. In a division-based layout, each part of a page that you want to format differently is separated into its own division. Think of the natural divisions into which you can divide the page that is shown here. These divisions might include the page title, a banner with selectable tabs, an area for the image, and further blocks for text and thumbnail images. The div tag was not introduced in HTML5, but is a good starting point for laying out a page or document. Then, you can use other HTML5 specific structural elements inside the div tag. Most HTML elements have a semantic meaning. In other words, the element describes either the function or the type of data that is contained within. For example, a P element is a paragraph that usually contains some text. In contrast, the div tag has no innate semantic meaning besides the logical grouping of the content. You can use these dedicated elements to mark up your website rather than using the generic div or span elements. An article defines a block of code that can be distinguished from the rest of the page. A section defines a logical separation in the document, such as the numbered chapters of an online manual. A header element is used to group the headers for a page. The footer defines the area at the bottom of the page. This code example shows some of the HTML5 structural elements. Here, the article element is used to create an online news report. The article includes a header. Within the article, the page is marked up into sections that have their own headers. The page also includes a footer element. The aside tag is used to provide additional information that is related to the main discussion. The aside tag lets you extract and display further content or go to additional resources without detracting from the main discussion. The figure tag defines a self-contained element that is referred to from the main content. The figure element can be used to embed graphics, images, or code sections. The fig caption tag defines the caption for the contents of the figure element. Websites typically have sections that are dedicated to navigational links that go to these sites or for moving between pages of a single application. In HTML5 syntax, these navigational links are placed inside a nav tag. The nav tag is a convenience tag for grouping navigational links in a web page. In this video, you learned tags provide control within an HTML5 document. Some tags provide structural elements. The div tag separates areas in a document into divisions, enabling you to apply different styles to different parts of a document. Dedicated elements like article, section, header, and footer are more specific than the generic div element. The aside, figure, and fig caption tags enable you to group content, and the nav tag enables you to group navigational links.
Welcome to HTML5 Input Element Attributes for the Input tag. After watching this video, you will be able to describe the attributes of the HTML5 input elements, explain the different input type attributes such as tell, email, date, time, number, range, and color, and importance of implementing validation fallback.
The input type equals color/attribute allows the user to select a color. The dialog varies depending on the browser, and some browsers don't support this input type. In non-supporting browsers, this input type is displayed as a regular text input field into which the user might type a valid color name or color code. The input type equals date attribute is a date control, year, month, day, with no time zone. The example shows the input type equals date field as it is seen in Google Chrome. The input dialog varies from browser to browser. The date time local attribute provides input for a date and time, year, month, day, hour, minute, AM, or PM with no time zone. The date time local input field is displayed as a drop-down calendar in the Google Chrome browser. The time can be typed or entered using the spinner control. The input type equals email attribute is displayed as a regular text input field. It provides feedback when the input does not follow the email format. The input type equals number takes a numeric value as input. You can optionally specify the minimum, maximum values, step size, etc. The example shows the number selector in the Chrome browser. Only the numbers between 5 and the 10 are available for selection. The input type equals range takes a numeric range as input. The example shows the number selector in the Google Chrome browser. Only the numbers in the range of the minimum and the maximum are available for selection. The range attribute displays a slider with a range of values between the minimum and maximum. Only the slider itself is shown. Additional JavaScript code is needed in order to display the value of the slider. The differences between input type equals search / and input type equals text / are mostly in style. WebKit-based browsers return a history of recently searched text strings. The search input field on the Safari browser has rounded corners. The input type equals tell pattern equals parameters attribute expects a telephone number as input. On its own, the input type equals tel provides nothing more than a text entry field in the browsers. It does not enforce numeric-only input since many telephone numbers include other characters, such as the plus sign and hyphens. You need to supply your own pattern matcher if you want the browser to validate the telephone number. The URL attribute is used to validate that the user typed in a properly formatted URL or web address. The input list equals some list uses the data list feature, not to be confused with the select element. The data list options are only suggestions, useful for autocomplete functionality. You can fill the list by nesting option elements inside the data list tag. These options are the types of fruits listed in the drop-down list. Placeholder text is used to provide hints of what the input text format looks like. The placeholder fills the input text field with the example values in a lighter shade of text. The form does not submit the placeholder text value if the input text is not overwritten. The required attribute implies that some text must be typed. The requirement to type some input applies even if the field contains placeholder text. What happens if browser-based validation is not supported for these input attributes? There are several options to performing validation in browsers that do not support all HTML5 input attributes. You can use JavaScript and jQuery libraries. You can assume that more browsers will support these features over time and leave all final validation to server-side processing. You can code client-side validation that is attached to the form submit event handler to validate all the fields on the form when the form is submitted. In this video, you learned common attributes of the input tag and how to implement validation fallback.
Welcome to Insider's Viewpoints, Enhancing the User Experience with HTML5. In this video, we will listen to several web development professionals discuss using HTML5 features that enhance the user experience. So, what are some of the exciting features in HTML5? And how do they enhance the user experience? Can you include some advice and best practices for the new learner?
HTML5 introduced several new input fields for web forms to enhance user experience. Developers can use these input fields to display customized virtual keyboard layouts and built-in data validation. For example, using an email input field, the user is shown a custom keyboard containing @ or a .com for handy autofilling of the field. HTML5 has native video support and can be directly built into the supporting browsers, which allow faster, high-quality videos to be distributed. This also has a positive impact on the SEO of a web page. HTML also supports geolocation, which is of tremendous importance when developing location-based applications or services.
ES6 brought in a lot of new features to JavaScript. It was a major revamp of the language. The one feature that I really like to use is that of promises when I'm working with asynchronous code or callbacks. So promises come in very handy. The other feature I like about ES6 are the new utility functions that were introduced in arrays. So array.fill, array.from, and find. Those functions not only make your code more readable, but are actually really effective as well.
Hello, and welcome to CSS, Styling HTML. After watching this video, you will be able to explain what a Cascade Style Sheet, or CSS, is. Describe how to use CSS to format HTML elements. Describe how to use CSS in HTML documents to format web pages. By using a combination of HTML5, JavaScript, and cascading style sheets, developers can create web pages that can be displayed on desktop computers and mobile devices. These technologies have powerful features that can be used to show rich interactive applications without requiring plug-in technologies like the Flash Media Player. HTML documents might be rendered to a browser window or through a speech synthesizer to provide assistive technologies for vision-impaired people. Being able to meet accessibility requirements is one advantage of using HTML markup over browser plugins for delivering interactive content. CSS is the design that is layered over the top of an HTML web page. CSS is a style sheet language that describes how HTML elements are displayed. What makes the style sheet cascading is that developers can apply CSS to create a uniform look throughout each element of each page of the website. Child and descendant elements often inherit styles that are defined for parent elements. However, exceptions to this rule do exist. For websites, it is an important concept to separate the data from the design. The data is sent to the browser by using HTML, and the design is applied to that data by using a CSS. This separation allows people to render a web page without your design if they have special accessibility needs. It allows machines, such as search engines, to index a website without the design interfering. You can code CSS as a style attribute in an HTML tag, a head section of a document, or an external document. The preference is to code CSS in external documents, referred to as style sheets. You can use CSS to control a document's appearance and specify style rules for the following web page elements: fonts, text, colors, backgrounds, sizes, borders, spacing, positioning, visual effects, tables, and lists. CSS style elements are structured like this. In this example, the HTML tag name can be one of the following elements: any tags you find in HTML code, for example, a, div, li, or label, etc. An ID reference that is displayed with a preceding hash symbol in CSS code. A class reference that is displayed with a preceding dot or period symbol in CSS code. When making a site design, begin by establishing the base style. Establish a base style by styling the body tag as shown here. This example makes the following styles. Sets the background color to off-white using background color. Ensures that the font color is black using color. Ensures that all content edges match the edge of the browser window frame using margin and padding. Horizontally aligns the textual content to the left using text align. Sets the font size to the browser's default using font size, and uses a sans serif, a font without the little flicks around the edges, as font family using font family. These settings are simple. Generally, follow these guidelines. When a color is specified, use red, green, blue, or RGB, hexadecimal light values. When a size is specified, use pixels, indicated by a PX after the number, an M, which is indicated by EM after the number, that is, the size of the font multiplied by the specified number, or a percentage, which is indicated by a % sign after the number. Text can be aligned left, right, or center. Floats can also be left or right. Vertical alignments must be top, middle, or bottom. Fonts can be any specific font or font family, serif, sans serif, or monospace, or even a downloadable font. One of the most important decisions you must make when you are determining the design of your website is whether to use a fluid or a fixed layout. A fluid layout is a layout in which the height and width of elements is flexible and can expand or contract based on the browser window, the operating system, and other user preferences. You specify these elements mostly by using percentages and ems. A fixed layout is a layout where you specify the height and width of elements, and those values remain the same regardless of which operating system or browser you use to access the website. You specify these elements mostly by using pixels. When determining the layout, consider also the pros and cons for fluid and fixed layouts. The type of layout you choose depends on the type and amount of content and the target audience of the website.
To apply a CSS, you must tell the browser where to look for it. This step is the only true point where HTML references a CSS. You can make the reference in one of three ways. First, there's inline CSS. This is used for a single HTML element, but the HTML document can get messy very quickly as more styles get added. To use this method, insert the style attribute inside any HTML element. Then there's the internal CSS. This is used for a single page, however, it dirties the page with a non-HTML code. If you copy and paste this style on each page, this approach increases the load time of each page, which causes the user to wait longer. To use this method, the style tag must be used with your CSS code inside. Finally, there's the external CSS. This method is used to style an entire website. You can link to it from other pages, which ensures a clean HTML and a smaller page size. To use this method, the link tag must be added to the head tag section in your HTML code. While it's not recommended, it is possible to use a combination of all three ways. In this case, if more than one CSS method points to an element, the type with the highest priority will override the others and be applied to that element. The order of precedence for CSS styles is inline CSS, which has a higher priority than internal CSS, which in turn has a higher priority than external CSS. In this video, you learned CSS creates a uniform look throughout each element of each page of the website. CSS design is separate from the data. Design can be removed for special accessibility renders, and search engines can index the website without the design interfering. CSS is usually coded in external style sheets, and you should create base styles for your website first. You also learned you must choose a layout type, fluid, where the height and width of elements is flexible and can expand or contract, or fixed, where the height and width of elements remains the same. And finally, HTML references CSS in three ways: inline CSS, internal CSS, and external CSS. Welcome to CSS Frameworks. After watching this video, you will be able to differentiate between the different types of CSS frameworks, list the advantages and disadvantages of each type of popular framework, and identify popular CSS frameworks and how to use them. Recall that a framework provides a foundation on which you can build your code. CSS frameworks specifically can provide you with all of the tools you'll need to spin up a basic user interface or UI. This makes it easier to implement various visual elements on a page, which can include navigation bars, forms, and grids, and to create dynamic and responsive websites, which can make a website suitable for any screen size. Since frameworks must be used from the creation of your project, it is important to know about different types of frameworks available. Different frameworks focus on different features, so it's important to identify which are the most important to your project when deciding which framework to use. There are two types of CSS frameworks: utility frameworks and component frameworks. Using no framework at all and just using plain CSS, also called vanilla CSS, requires you to write all of the styling on your own. This gives you the freedom to style everything exactly as you want it, but also requires a lot of time and effort as you must style every component. An alternative to this is to use a utility framework, which gives you utility classes that scope to a single CSS property. This makes it easier to apply CSS properties directly in your HTML code, which can save a lot of time, while still giving you the freedom to style components as you wish. Component frameworks provide you with pre-styled components and templates, which are easy to add to any website. This requires little knowledge of CSS and makes it easy to keep consistent styles, but also limits you to only the components made available by the framework. Utility-first frameworks provide you with an easy way to reference CSS properties. These typically come in the form of classes called utility classes, which scope to single-purpose CSS classes. Instead of having to write out the entire CSS property, utility-first frameworks allow you to use a property by referencing its corresponding class within the class attribute of your desired HTML element. For example, instead of using the text-align : center semicolon CSS property in your code, a utility-first framework might have a self-descriptive class, such as text-center, which does the same thing when added to the class attribute of an HTML element. They make it easy to be consistent with color choices, spacing, typography, shadows, and everything else that makes up a well-engineered design system. However, having these styles mixed into your HTML classes reduces the separations of concern within your code, making your HTML markup more verbose. Since utility-first frameworks involve adding many classes to your HTML markup, this often causes the download size of your markup to increase and potentially slows down your web pages. A popular utility-first CSS framework used today is Tailwind CSS. It is packed with classes that can be composed to build any design directly in your markup. For example, say you want to style a link to indicate it's dangerous. You could underline the link text and change the text color to be red, as well as make the link a darker shade of red when hovered over. Doing this in vanilla CSS would require this code where you need to specify what the link looks like regularly and when hovered over in two separate sections. However, with Tailwind CSS, it can easily be done within the class attribute directly in the HTML, which can save a developer time. The hover portion of the Tailwind CSS is a special type of class called a modifier, which can be used with any other Tailwind class and is only applied when a user hovers over that element. There are many instances of modifiers in Tailwind CSS, some of which can make it very easy to create responsive websites fit to any screen size. For example, adding MD: before a class will only apply the class when a user's screen size is greater than 768 pixels wide, which is defined by Tailwind as a medium-size screen. This code will display an image with a width of 16 or 64 pixels by default, a width of 32 or 128 pixels on medium screens, and a width of 48 or 192 pixels on large screens. This saves developers a lot of time when styling many different elements, allowing them more time to focus on the back end. It also provides them the freedom to style elements however they want. Component frameworks provide pre-styled components which can be easily added to your code. This results in the ability to develop well-styled websites rapidly as significantly less time needs to be spent styling each element. It also makes it easier to keep all related elements styled uniformly, as you can simply choose the same or similar styles each time. However, having all of these predefined styles limits you to only what the framework provides and doesn't give you the freedom of customizing everything exactly as you want it. They also provide a lot of overhead code that you wouldn't otherwise get if you choose not to use any frameworks, as component frameworks will often provide you with more components than what you'll use. One of the most popular component CSS frameworks in use today is called Bootstrap. It allows you to build fast, responsive websites with a feature-packed front-end toolkit. If we take our example of adding a red danger link to your web page, which we saw earlier, we can see how much easier this would be with Bootstrap. Recall how to add this with vanilla CSS and Tailwind CSS. Now, Bootstrap provides a red danger link as one of its many components, and so adding this can simply be done by using the link danger class. Seeing all of these side by side, it becomes clear that For this example, Bootstrap has the easiest implementation of a danger link. However, this may not always be the case. In addition to providing individual HTML components such as buttons and links, Bootstrap also supplies entire templates which range from anything as comprehensive as an entire website to a simple sign-in page. As a whole, all of Bootstrap's components and features save time designing web pages and make it easy to remain consistent with styles throughout a website. Its ease of use also means that you don't need to be an expert in CSS to use it. Only limited knowledge is needed to use its basic features. However, it is important to keep in mind that it's limited in the components it can provide and may not have the ones you're looking for. In this video, you learned that CSS frameworks make it easier to implement UI elements and create mobile-friendly web pages. Plain or vanilla CSS lets you write all of the styles and layouts of a website on your own. Utility-first frameworks provide you with utility classes to help you build your own styles and layouts. Tailwind CSS consists of classes that are composed to build designs directly on the markup. Component frameworks provide you with a wide selection of pre-styled components and templates which can be implemented onto your website. And Bootstrap allows developers to build fast, responsive sites with its feature-packed front-end toolkit.
Hello, welcome to the JavaScript language, overview, and syntax. After watching this video, you will be able to describe JavaScript primitives and objects. JavaScript is a scripting language that is derived from the ECMAScript standard and originally designed to run on the Netscape Navigator browser. Virtually all browsers now support JavaScript. Although the name Java appears in the word JavaScript, the two languages are not related. When a JavaScript interpreter is embedded in a browser, the result is the ability to create dynamic web pages. JavaScript adds behavior to otherwise static web content. The content of a web page can be dynamically changed with the scripting capability of the JavaScript interpreter. JavaScript code acts on the document object model that the web browser generates. One of the ways that server programming and browser scripting work together is an architecture that is called AJAX, or Asynchronous JavaScript and XML. The term AJAX encompasses more than asynchronous server calls through JavaScript and XML. AJAX represents a series of techniques that provide richer, interactive web applications through HTML, JavaScript, cascading style sheets, and modifying the web page through the document object model. Nowadays, JSON is commonly used instead of XML. In JavaScript, there are 5 primitive types that are associated with various primitive values. Number, all numbers such as 0 or 3.1412. String, all strings such as hello world. Boolean, the values true or false. Null, the value null. Undefined, the value undefined, since a data type has not been assigned or the variable does not exist. All other non-primitive data types are objects. The number primitive represents both integer and floating point values. The value NaN, not a number, and infinity. Integers can be coded as base 10, decimal, base 8, octal, or base 16, hexadecimal values. The integer literal, 16 in decimal, 020 in octal, and 0x10 in hexadecimal all have the same value. All numbers in JavaScript are represented internally as double precision, or 16-bit floating point numbers. JavaScript strings are delimited by either double or single quotation marks. There is no behavior or methods that are associated with primitive data types. The primitive types number, string, and Boolean can be wrapped by their object counterparts. Wrapper objects have the same name as the primitive type, except that they start with an uppercase letter. Like most object-oriented programming languages, JavaScript provides built-in ways to convert between these wrapper objects and primitive values. The wrapper objects use special methods such as the value of and toString methods to convert between objects and primitive literals. The type of keyword in JavaScript is used to find out the data type of the supplied operand. Notice how strings created without the new keyword have a type of string. The keyword new is used to create the string wrapper object. This object can be converted to a primitive string type by calling the value of function on the object wrapper class. Arrays are specialized collection objects that aid the programmer in the storage and retrieval of data by indexed keys. Arrays use a zero-based indexing scheme, meaning that the first element of an array has an index of 0. Arrays grow or shrink dynamically by adding or removing elements. The length property holds the number of elements that occur in the array. Arrays can be declared by using either an array constructor or an array literal. When declaring an array with a constructor, you use the new array keywords and specify the array elements as parameters of the new array. Array literals are created by declaring the array elements within square brackets. You then assign the array to a variable, as seen in the last example on the slide. The date object is a specialized object that is used to hold the date and time. The constructor for a date object is in the format newDate and takes optional parameters. If you create a date object without any parameters, JavaScript returns an object that contains the current local date and time. If you send this date object to the console or try to display the date object on a web page, JavaScript automatically applies a toString method to the object. The result that is displayed is a string version of the date as shown on this slide. You can also create new dates by passing parameters to the newDate function. Examples on the slide show how either string or numeric values can be used for the date parameters when creating new date objects. As with other object-oriented languages, JavaScript creates error object instances when an exception occurs. The error object instance includes two properties that contain information about the error. The message property contains a description about the error. The name property identifies the type of error, such as a range error. A range error is an error instance that is created when a numeric value or parameter is outside its valid range. Besides a generic error, there are 6 other core error types in JavaScript, 3 of which are shown on the slide. The other 3 are eval error, reference error, and syntax error. The error object can be extended to create custom error types. The last line of the slide shows the creation of a generic error object with a custom error message in the parameter field. In this video, you learned JavaScript is a scripting language that adds behavior to otherwise static web content. Primitives are values and have no properties or methods. Examples of primitives include number, string, Boolean, null, and undefined. Wrapper objects allow objects of corresponding primitive data types to be created. Wrapper objects can store a primitive value and provide methods with which to process it. Wrapper objects have the same name as the primitive type, but they begin with a capital letter to differentiate them from the primitive data type itself. Some examples of wrapper objects are array, data, and error objects.
Welcome to JavaScript Variables and Control Statements. After watching this video, you will be able to define JavaScript variable declaration, show how JavaScript uses variables, and identify JavaScript control structures. Variables are containers for storing data values, which can be used and modified throughout a program's execution. Variables in JavaScript are declared with the var keyword, followed by the variable name, as in the example var age. Variables can also be declared and initialized in one step, as in the example var age equals 54. You can assign a value to the variable at a later time or reassign the value of a variable. Since JavaScript is a loosely typed language, you do not need to declare the data type of a variable. The variable assumes the data type from the value of the field during assignment, and the type of a variable can change during program execution. Be careful about not initializing variables and not assigning them a value. If a variable is not assigned a value, then the value is not 0 or an empty string or any other default value. The variable value is undefined. Remember that the only keyword is var, and JavaScript has no way to know whether the variable is a numeric or a string or anything else until you provide a value. Therefore, by default, it cannot decide whether to assign a 0 or an empty string. Variable names or identifiers have the following rules. The name must start with a letter, underscore, or a $sign. Subsequent characters can also be digits 0 to 9, and identifiers are case-sensitive. Variables also have a scope. Variables declared within a function have a scope local to that function. This means that they exist within the function but not outside of it. Variables declared outside of a function have a global scope. Variables with a global scope can be used elsewhere in the JavaScript program. And variables declared without the var keyword have a global scope. Variables that are not initialized have a value of undefined. You'll learn about functions shortly.
Conditional statements are the set of commands that are used to perform different actions for different conditions. In JavaScript, the if statement is the way the program logic decides which path to take based on the current values of variables or object properties. The JavaScript syntax for a decision begins with the keyword if, followed by the condition to test, then the statements that run if the condition yields a true result. The true processing follows immediately after the test condition and is delimited by braces, unless it is a single statement. If the condition resolves to false, the statements that follow the else keyword are executed. Indentation of the statements of a compound control statement is not required in JavaScript. However, a programmer can find that indentation helps in deciphering the control statement. Many JavaScript-aware text editors automatically indent the control structure to make it more readable. Unlike Java, there is no block statement scope in JavaScript. Having no block statement scope means that variables declared inside one if condition can be used outside the scope of that condition. JavaScript supports the switch statement as an alternate to the if, then, else control statements. The condition that is being tested is placed in parentheses that follow the switch keyword. The expression parameter of the switch statement can evaluate to any number or string value. The labels in the case statement are enclosed in quotation marks when the labels represent string values of the expression. The program looks for a case clause with a label that matches the value of expression and then transfers control of that clause, running the associated statements. If no matching label is found, the program looks for the optional default clause, and if found, transfers control to that clause, issuing the associated statements. The break keyword is used to prevent the code from automatically falling into the next case clause. The for loop repeats a series of statements for any number of times. The for loop takes 3 parameter arguments, namely the initial value, the condition that is being tested, and the increment expression. When the for loop runs, the following occurs. First, the initial expression is set. Second, the conditional expression is evaluated. If this condition evaluates to true, the loop statements run and the increment expression is updated. If the condition evaluates to false, the for loop terminates. If the loop does not terminate, control returns to the second step and the conditional expression is evaluated again. The while loop is another common loop in JavaScript. The loop repeats while the condition remains true. The while loop assumes that the condition reaches a conclusion and then exits the loop. Make sure that the condition evaluates to false at some point, otherwise the loop never terminates. In this video, you learned variables are declared using the keyword var followed by the variable name. You can initialize variables at the time of declaration or assign a value later. You do not need to declare the data type of a variable. Variables take their data type from the value assigned and can change type during program execution. Variables also have a scope. Variables declared within a function have a scope local to that function. Variables declared outside of a function have a global scope. Variables declared without the var keyword have a global scope. When executing, the flow of the program is directed by control statements, including conditional statements like if, then, else, switch statements, repeat statements like for loops and while loops.
Welcome to JavaScript Functions and Prototypes. After watching this video, you will be able to describe functions in JavaScript, describe prototypes in JavaScript, and demonstrate how to create a custom object.
A function is a block of code which can be called from any point in a script after being declared. A function is made up of the following parts: the keyword function, the name of the function, parentheses with optional parameter arguments, curly braces with the logic. The last statement in a function block is the optional return statement that returns control back to whatever called the function. This example is a function that is named add. This function takes two parameter arguments and returns the sum of the arguments or concatenates the two arguments if they are strings. Notice that you do not specify the data type for the arguments of the function. The data types are determined by the values of the arguments that are being passed to the function. There is no specific return type declared. The function returns whatever type is required. In this case, the return is a simple addition or concatenation of the input parameters. The action chosen depends on what data is provided to the function. If the values can be interpreted as numbers, they are added. If they can be interpreted as strings, they are concatenated.
This is an example of declaring a function named car that accepts 3 arguments as parameters. A little further down, you specifically ask the function to run by declaring the statement var c equals new car with the arguments Meridian, Sabre GT, and 2012. In the car function, the keyword this refers to the current instance of the car object that is being created. In other words, an instance of car that is associated with the variable named c. Using the this keyword can differentiate whether you are referring to the global or local instance of a variable. The use of model in this example refers to the argument that was passed into the function, while the use of this.model refers to the global model variable associated to this instance of the car object. The getName function of car returns the make, model, and year of the newly created car object. Prototypes allow you to easily define properties and methods for all instances of a particular object. All JavaScript objects which can be created with the new keyword inherit properties and methods from a prototype. For example, the car object we created previously inherits the make, model, and year properties from the constructor function, which are implicitly defined in the car prototype. When a car object is created, that object inherits all the properties and methods that are defined by this prototype. Unlike objects, the methods and properties of prototypes can be changed with one call. So, if you want to add a new property to an object's constructor function, for example, you must add it to the function directly by adding it as an additional argument. It cannot be done simply by calling the object itself. With a prototype, however, it is possible to add a property or method with just one call. Since all objects have a prototype property, this is an easier way to add properties and functions to objects. Any object that gets instantiated inherits the current state of the prototype. If a prototype changes, all objects using it will automatically inherit the new properties and functions within that prototype. One way to change a prototype is via a script, which can override prototype properties and functions.
Here is another example that uses a prototype to change car instances. This time, you add a method function called getName to the car prototype. Now, when a car object is instantiated, it also includes the getName function that returns the make, model, and year. All existing instances of the car object also inherit the getName method. Functions are usually declared first and not run until you specifically ask them to, as you saw in some of the previous examples. Auto-invocation or self-executing functions start running immediately after being declared. The functions and variables inside self-executing functions are only available to the code inside the self-executing function. Auto-invocation functions can also be unnamed or anonymous functions and have the format that is shown in the code block on the slide. Self-executing functions are often used to initialize data or to declare DOM elements on the page. In this video, you learned a function is a block of code which can be called from any point in a script after being declared. Functions can take arguments passed as parameters and can return results. By using prototypes, you can easily define properties and methods for all instances of a specific object. Prototypes exist for all JavaScript objects that can be created with the new keyword. To add a new function to the template for the object, modify the prototype for the object. Self-executing or auto-invocation functions start running immediately after they have been declared. The functions and variables are isolated from the rest of the script.
Welcome to JavaScript APIs. After watching this video, you will be able to explain how to work with nodes, describe how to modify the content of an element, explain how to modify the inline style and attributes of an object, and describe how to use the window object methods and events.
The DOM Level 1 core and Level 1 HTML specifications have too much detail for one unit. Instead, the remainder of the unit focuses on script functions and properties that are commonly used when working with HTML pages. Some of these common APIs used when accessing HTML DOM elements in web pages are seen on the slide. DOM elements are reviewed next. To retrieve a node referenced for an element of a document given an ID, use the document.getElementById function and pass the ID value as an argument. This returns one specific HTML or XML element if a matching unique ID is found on the web page. The getElementsByTagName function retrieves a node list of elements with a specified tag name. The node list contains an array of elements in your document. You provide the name of the element you are interested in, and an array of all elements with that name found in the document is returned. For HTML elements, the tag name parameter is the literal name of the HTML tag. If you run the function getElementsByTagName with a p as a parameter argument, a node list of all the paragraphs in the document is returned. This example shows how you can retrieve all the image elements from a web page by using the getElementsByTagName function and passing image as the parameter argument. The result is a node list that is assigned to the variable image set. In the next part of the code, you loop through the node list and concatenate the results into a DOM output stream. The src attribute is a common property for the image tag. The src attribute indicates the location of the image source. The document.write function adds the script-generated HTML to the document. You can use the DOM API function document.createElement tag name to create an element in the current document. After creating the element, you can use any number of functions to place the element in the appropriate location within the document. Examples of these functions include the insert before, append child, or replace child function that can be used to add the newly created element into the document. This example shows the source code for adding a node to a document. A new paragraph element is being created that includes a text node with the string "Hello World." The text node is then appended as a child of the paragraph element. Finally, the entire paragraph with text is appended as a child node at the end of the body node of the HTML page. The function element.innerHTML retrieves or sets the contents of an HTML element. The inner HTML property returns all child elements as a text string. With the element.innerHTML function, you can change the contents of an HTML element by setting it to a text string that can include HTML tags. Setting the inner HTML value of an element to a string removes all of the current child elements. The browser then parses the string and sets the contents of the HTML element. You can use the element.style method to retrieve or set the inline CSS style for a particular element. If you use element.style to set the style of an element, it overrides any setting from a CSS style sheet with one specific style. The way to set the style in JavaScript is with the format element.style.propertyname equals value. For example, if you had an element, div style equals color:blue. Here, the div tag is used to group block elements to format them with a color style. You can change the style of this div tag with the JavaScript statement div.style.color equals red. In contrast, the element.set attribute style wipes out all previous set inline CSS styles. The function element.set attribute with parameters attribute name, attribute value dynamically modifies the attribute of an element. In the example, the src attribute of an element with an ID of the image is set to a different target image. The function element.remove attribute name removes an attribute from an element. The function element.get attribute name retrieves the value of the specified attribute in the element, if it exists. Here are some window object functions and events. To open a new browser window, use the window.open function. This method returns a reference to the new window object. You can use this reference later to close the window with the reference name followed by the close function. The parameters of the window.open function are URL, a string that indicates the location of the web page to be displayed in the new window. You can pass an empty string if you are going to write some script-generated content to the new window in the current URL content. Name, a string that specifies the name of the window. Features, an optional string that specifies the features of the window, such as its placement and dimensions. The features string is a comma-separated list of name-value pairs. Replace, an optional Boolean value. If true, the new location replaces the current location in the browser history. The window.onload function can be used to start a function after the page is loaded. The function window.dump message writes a string into the console for the web browser. The dump function is a less intrusive way to display diagnostic information than the alert method. Finally, the window.scrollTo, X value, Y value, scrolls the web browser to a particular set of coordinates on a page. The onload event handler runs in the current window after the documents load the web page. In this example, the onload event causes an anonymous function to run. This function, in turn, runs the function addPara. In this video, you learned you can retrieve a reference to a node using document.getElementById returns one specific element that is based on the ID attribute. Document.getElementsByTagName retrieves elements with the specified tag. You can create an element using document.createElementTagName and place it using insertBefore, appendChild, or replaceChild. You can modify elements using element.innerHTML to retrieve or set the contents of an HTML element, element.style to retrieve or set the inline CSS style, element.attribute to modify the attributes of an element. You can manage a window object using functions including window.open to return reference to a new window object for the web browser, window.dump message to write a string into the console for the web browser. This is not an exhaustive list. Many more functions exist that enable you to work with HTML elements and nodes.
Welcome to client-side JavaScript with HTML.
After watching this video, you will be able to define a client-side script, give examples of when client-side script can be used, explain how to use the NoScript tag, describe event bindings in scripts. A client-side script is a program that accompanies an HTML document, or might be embedded directly in the HTML document itself. The script program runs on the client device when the document loads, or at some other time such as when a link is activated or when a button is clicked. Although JavaScript is widely used as a scripting language in HTML, other scripting languages can be used instead. Scripts offer authors a means to modify and extend HTML documents in highly interactive ways. Scripts can run after an HTML document is loaded. Scripts can be used to validate forms or to process input as it is typed. Scripts can be triggered by events that occur on a web page, such as the clicking of a button. Scripts can be used to dynamically create document elements on an HTML page. This slide shows two ways in which the script tag is used to include scripts in an HTML document. Example 1 demonstrates how you can include a script directly inside the HTML document. This method is good for short scripts, but when a script is long, the method used in example 2 is preferred. Example 2 uses the src attribute to point to an external script file. This method has several use cases, such as importing JavaScript libraries for complex interactions or using the same script across several HTML documents. Some users who visit your website might disable JavaScript from running, or they might be using a browser that does not support scripting. To allow for these situations, place the content for the alternative path within the NoScript tag. If the browser does not support scripting, the browser runs the section of the code that is within the NoScript tag.
Scripts can run on the detection of certain events that happen when the page is running in a browser session. Calling a function when an event occurs is called event binding. For example, the onload event can run a script when the browser finishes loading a page, or a function can be performed when the onClick event occurs. This event occurs when the pointing device is clicked over an element, such as a button, that declares a handler for the event. The event handler is a function that declares what to do when the button is clicked. Other useful events include onMouseOver, which occurs when the cursor is moved onto an element.
Here, the inline event handler named showAnswers runs when the button is clicked. In this video, you learned a client-side script is a program that accompanies an HTML document. It may even be embedded into the HTML itself. Scripts offer developers ways to extend HTML documents to enhance the user experience, especially by incorporating more interactive elements. You can use the script tag to include a script within the HTML document, or to call a script from an external file. Use the NoScript tag to provide an alternative when scripting is disabled. Scripts can be bound to events so that they run automatically. For example, the onload event can run a script when the browser finishes loading a page.
Welcome to Insider's Viewpoints, JavaScript Best Practices. In this video, we will listen to several web application professionals discuss best practices from their experiences with JavaScript. Can you share with us some best practices from your experiences of working with JavaScript?
Okay, I want to share 3 best practices that I've learned over the years working in this field, especially with JavaScript. So first is use of IDEs. I love using something like VS Code or WebStorm to write code. The content assist and being able to look up functions and documentation and classes all within the same editor is very powerful to me, and it's very effective. It makes me a more productive developer. My second advice would be to use linters. So if you're new to JavaScript and you don't know what linters are, they help you write standard code. Now, I don't mean standard in terms of ES6 standard, but this could be standard in terms of how your team decides to write functions and documentations. And this is very important when it comes to version control and resolving conflicts. It makes your life a lot easier. And finally, my third tip would be to learn the different paradigms and patterns in JavaScript. So assuming you're using JavaScript for your front end and or back end, learn how to modularize code in JavaScript. Learn how to then import structure your code so it's easier to unit test. Structure your code so it's easier to import other packages into your application.
So working with JavaScript has changed a lot over the years. It's actually pretty robust nowadays, and there's a lot of tools you can use for it. I definitely would recommend linting your JavaScript. One really great tool that I personally use is called XO, spelled XO. It's a great linter that has some great default set, and you just run that on your code, and it makes you follow specific standards, styles, so that you and everyone on your team make sure that your code looks good, but also hopefully reduce the amount of bugs and confusion in your code. I'd also recommend using TypeScript. It's a wonderful addition to JavaScript that often can just be plonked right on top of a current JavaScript project without needing to change much code at all. And then you can add a whole significant set of features onto your code to make it much better.
While working with JavaScript, avoid declaring global variables and functions. Global variables can slow down your program since they are not deleted until the window is closed. Also, scripts that include same variable and run after your code will override your variables. In order to reduce page load times, place your JS at the bottom of your page, especially if the purpose of JS is to add functionality after an event occurs. When declaring lengthy for statements, declare variables outside of the for statement. You should also optimize loops. For example, instead of reading the length attribute of an array at every iteration, store the length value in different variable. Always comment important sections of your code so that you or your colleagues can understand the purpose of the code when you need to revise your code.
So when writing JavaScript, I really like to take advantage of the features in ES6 because it can make my code look cleaner, easier to read, and just more beautiful. Such as the arrow functions or the ... operator. And so I encourage you to, after learning JavaScript, dive into ES6 a bit and have fun with it.
One best practice for JavaScript developers to keep in mind is to avoid the use of global variables. You might have heard this advice for other programming languages as well, and the reasons there apply here as well. But with JavaScript specifically, the risk of name collision is quite high. So it's very common for developers to include their code as well as third-party libraries on the same page. And all of these scripts will share the same global context, which means if you happen to pick the same name for a global variable as one of those third-party libraries, basically one or both of your programs will not work.
JavaScript is a very powerful language. It lets you do pretty much anything you can imagine, including shooting yourself in the foot if you're not careful. The practices I typically follow with JavaScript include proper scoping of variables and functions, and writing unit and integration tests for my features.